All right, this is our Algebra 1 weekly review, number 17. Question 1 in the first row, we need to graph that linear equation. The linear equation is in standard form, so to do standard form, we like to use x and y intercepts. To find the x-intercept, we put 0 in for y, and we solve for x. Now if I put 0 in for y, that means the term with y would no longer be there. Our x would equal 4. Then to find the y-intercept, I would put 0 in for x. So that means the x term would no longer be there. Be very careful, there's still a negative 4 in front of the y. So we would have to divide by negative 4. Our y would be negative 1. X is 4, so I put a point at 4 on the x-axis. The y is negative 1, so I put a point at negative 1 on the y-axis. Connect, and you have your graph. The second question in the first row, we again need to graph the linear equation, which will give us a straight line. We have slope-intercept form, y equals mx plus b. So m is our slope. We have a slope of 2/3. 2 is a positive direction, so it means we're going to go up 2. 3 is also positive, so it means we're going to move to the right 3 for our slope. To get the starting point of our graph, we need the y-intercept. The y-intercept is at 3. The coordinates would be 0, 3, if that helps you graph. So on the y-axis, I go to 3. My slope then tells me to go up 2, right 1, 2, 3. Up 2, right 1, 2, 3. You only need 2 points to make a line. The third question in the first row says give the linear expression that defines the following sequence. So in order to do that, we need to find that constant rate of change. So as I look for my pattern, to get from 6 to 2, we would subtract 4. 2 to negative 2, we would subtract 4. Negative 2 to negative 6, we again would subtract 4. So we have that constant difference of 4, or our rate of change. Could also be called our slope if you'd like, if this were an equation we needed to write. So I've got my constant rate of change. Now I just need to find what that quote-unquote 0 term would be. So if I work my way backwards in the pattern, instead of subtracting 4, I would add 4. So that term 0, if you will, would be 10. So if I go to write my expression, I would have negative 4x plus 10. So it's similar to writing an equation. Negative 4 would be like your slope. 10 would be like your y-intercept. Our final question in the first row, we need to solve the equation for x. We start by undoing the addition by using subtraction. So we are left with negative 3x equals 3. Divide to undo the multiplication. And we get x equals negative 1. Now you can also substitute that back into check. So I could do negative 3, replace x with negative 1, plus 5, and make sure that that left side does in fact equal 8. So we get positive 3 plus 5. Does that equal 8? And yes, it does. So that side checks out. First question in the second row. We need to solve that equation for h. We want to get h by itself. The first step I would do, what's going to be simplest to do, is take care of the fraction first. We're multiplying by 1/3 on the right, so to undo multiplying by a fraction, we would divide by a fraction. Dividing by a fraction is the same as multiplying by its reciprocal. So I'm going to multiply both sides of that equation by 3. So we're going to have 3 capital V equals, I have pi r squared h. And then to finish getting the h by itself, we have a pi times r squared times h. So to undo all the multiplying, I'm going to go ahead and divide by pi r squared. So 3v divided by pi r squared will equal RH. Don't worry, this is not a formula I want you to memorize. It's you being able to manipulate the equation to get a specific variable by itself. So in this case, h. Second question, second row. We're solving an absolute value equation. Remember, the absolute value bars are different from parentheses. I cannot distribute the 2. Usual equation solving rules apply. I'm going to undo the subtraction first by using addition. And I apologize, guys, the tip of my stylus is broke, so that's why there's a little bit of incompleteness when I write. 7 plus 3 gives me 10. Now again, I cannot distribute the 2. So this means 2 times the absolute value. So to undo 2 times, I need to divide by 2. So I end up with the absolute value of x minus 4 equals 5. Absolute value, remember, there's 2 different numbers whose absolute value is 5. Absolute value means the distance we are away from 0. So positive 5 has an absolute value of 5. So does negative 5. So you need to make sure you have your positive and negative case when you're solving with absolute value. And the question I usually get is, do I have to have both solutions? And the answer is yes, you do. You do need both solutions. All right, our third question in the second row. We need to solve the inequality. The same rules as solving an equation apply here. Start by undoing addition or subtraction first. And then next we're going to undo the multiplication by using division. The one small rule we have to remember with inequalities is that if we multiply or divide by a negative, we have to flip our inequality symbol. So I have negative 1. My greater than or equal to is going to become a less than or equal to. And then we have our x isolated over on the right-hand side. When you solve an inequality, you also need to graph the solution on the number line. So at negative 1, we have an equal to, so we're going to have a closed circle. Some values that I could put in for x so that inequality is true would be 0, positive 1, positive 2. Remember, you can't always shade the way the symbol's pointing. You have to shade values that'll make the inequality true. So negative 1 less than or equal to, if I put 0 in there, that checks out. But if I have negative 1 is less than or equal to negative 2, that doesn't work. So I need to shade to the right. Last question, the second row. We once again are solving an inequality. There's multiple ways you could start solving this inequality. You could add the negative 2x. You could add 1 to both sides. You could add 5x to both sides, or you could subtract 8. When solving, I like to try to keep my variable positive. If I keep my variable positive, I don't have to worry about remembering to flip the inequality symbol because I won't divide by a negative or multiply by 1. So I'm going to start this by adding 5x to both sides. Now sit tight if you solved it a different way, because like I just got finished saying, there's more than one way to solve this. There's actually 4 different ways. So we have 3x minus 1 is less than or equal to, we still have an 8 over on the right side. Add 1 to both sides. 3x is less than or equal to 9. Divide both sides by 3. X is less than or equal to 3. We have an equal to again, so we have a closed circle on 3. I need numbers that will make the inequality true. So I need values that are less than 3. Those are going to be values like 2, 1, 0, and anything negative. So that completes our second row. Our third and final row on the front side of our sheet, we're going to start by solving an absolute value inequality. So when we go to solve the inequality, the same rules apply as when we started with our equations. We need to get the absolute value bars by themselves first. So if we take a look at this question, there's a negative in front of those absolute value bars. There's really, and if you need to write it in there, you sure can, there's really a -1 there. So it's -1 times the absolute value. Remember, we cannot distribute over absolute value bars. So to undo the multiplication, we need to divide by -1. When that happens, we end up with the absolute value of x minus 1. We divide it by negative, so we have to flip the inequality symbol, and then we end up with -8. So now we're trying to find the absolute value, so it's less than -8. Absolute value is a distance from 0. Absolute value, the result of an absolute value is always positive. So the left side of our equation, or excuse me, our inequality, the result's always going to be positive no matter what value I put in for x. The result of taking the absolute value of a number is always going to be positive. So I cannot have a positive number be less than a negative number. So this one is not possible. This one has no solution. Because the absolute value, which is a distance, it cannot be negative, so it cannot be less than a negative. Second question in the third row, a simple inequality to solve. All we're going to do is divide both sides by -2. But now when you do that though, this one, the reason why I wanted to do this question is to really once again hit home the idea that if you multiply or divide by a negative, you have to flip your inequality symbol. So we have to graph. This time we have an open circle because there's no equal to. Values that are less than -5 are things like -6, -7, -8. So we're going to shade to the left. Third question in the third row, we're going to solve the system. We're not specifically told whether we have to use substitution or elimination or if we're supposed to graph. So when I look at this system of equations, one reason I would not choose substitution is because I don't see a coefficient for x or y that's already a 1 or -1. So trying to get an x or y by itself could result in some fractions or decimals, and I don't want to have to work with those when solving. So I'm going to see if maybe elimination might work. To do elimination, we need to create a pair of opposites. So that means I need a positive and a negative of the same value for x or for y. So I'm going to check out the x first. I have a -2 and a +3. There's nothing, no whole number, integer, that I can multiply -2 by and get 3. There's no whole number or integer that I can multiply 3 by to get -2. Same situation is going to happen with the y's. So what I need to decide is, if I take a look at the x's, can I find a manageable number that both of them can go into? Yes. -2 and 3 could both go into 6. So what I'm going to do is I'm going to turn the x coefficients into -6 and +6. So I'm going to multiply the first equation by +3, and I'll get -6x plus 12y will equal 3. Then the second equation I'm going to multiply by +2, so I get 6x minus 12y equals 18. When I add those two together, the -6x and +6x, they will be eliminated, and that was our goal. But now in this system, though, now I look at the y values, +12 and -12, they're going to eliminate as well. So over on the left-hand side, I'm left with 0. I'm left with nothing. The equal sign comes down, and now I have 3 plus 18, I have 21. I don't have any x's or y's left, and I'm left with an answer, a solution that doesn't make sense. 0 does not equal 21. So this system would not have a solution. Last question for this front side. Rebecca is a star basketball player. In one game, she had 23 points made up of 2- and 3-point baskets. She didn't shoot any free throws. If she made 4 more 2-point baskets and 3-point baskets, how many of each did she make? So in order to solve this, we're going to have to set up a system of equations. We're looking for how many of each type of basket did she make. So I'm going to let x be number of 2-point baskets. And I'm going to let y equal number of 3-point baskets. So now what we have, she had 23 points made up of 2-point and 3-point baskets. So she's going to have, make sure I have enough space here. I'm actually going to write over here a little bit to make sure I have enough space to solve. So she had 23 total points. So each 2-point basket is worth 2 points. So how much one is worth times how many she made. How much a 3-point basket is worth times how many she made, and it'll equal 23 points. Now, realistically, could you sit there and guess and check your way through this? Yeah, you probably could. But let's use the information we have, because I don't want to sit here and guess and check all day. So now the other piece is, she says she has 4 more 2-point baskets than 3-point baskets. So that means her number of 2-point baskets, to get that, it would be her number of 3-point baskets plus an additional 4. So she made 4 more 2-point baskets than 3-point baskets. So her number of 2-point baskets would equal her number of 3-point baskets plus 4. This system is conveniently set up for substitution. The x is already by itself, which is awesome. So we're going to take what x equals and substitute it in for x. So we're going to have 2 times y plus 4 plus 3y equals 23. Distribute the 2. Combine our like terms over on the left side, 5y plus 8. Subtract 8 from both sides. 5y equals 15. Divide by 5. And our y equals, we have 3 3-point baskets. Now we do also need to find the x. So the easiest way to do that is take what y equals and put it back in one of the equations for y. The easiest one is going to be the second one. So x equals 3 plus 4. X equals 7. So if we want to, we could check that out. You could substitute back in. X is 7, y is 3. So 14 plus 9, it gives us 23 points. We check out. As we go to the back side of our sheet, the first question we see, it asks us to solve using substitution. This one isn't conveniently set up for it, like our last question was. We're going to have to do a little bit of extra work. In the second equation, though, we could easily solve that one for x or for y. It's your choice. I'm going to solve it for x. So when I substitute into the first equation, I have a positive that I'm distributing instead of a negative that would be with the y. You could substitute for either one. I'm going to get x by itself by subtracting y from both sides. So now I have x equals 8 minus y. I take what x equals, I substitute it in for x in that first equation. So 3 times 8 minus y minus 2y equals 19. Distribute the 3. On the left side, we can combine the y's. So we'll get negative 5y. Subtract 24 from both sides. Divide both sides by negative 5. And we arrive at y equals 1. We do have to remember we also have to solve for x. So take what y equals and substitute it into the equation that's already solved for x. And we get x equals 7. So 7, 1 would be our solution for that. Now this next piece you may or may not be familiar with. So let's take a look at entering those data values into our calculator. I want to show you how to do this on the graphing calculator. It's the easiest way I know how to do it. So if you have your graphing calculator handy, what we're going to do is put those values into our lists. To get to your list, press the second key and then the stat key. Oh, just kidding, sorry. Just press the stat key. There we go. So not second stat. Just press the stat key and we're going to press edit. You might have lots of things entered into your list. We're going to clear those out. Use your arrow keys so list 1 is highlighted like it is on my screen. Press the clear button, press enter. Do the same thing, highlight the top of list 2. Press the clear button, press enter. So arrow back over to the first entry in list 1, and we're going to enter 5, 7, 9, 11, 13, 15, and 20. Into list 2, 406, 499, 588, 666, 721, 769, and 1020. Always just do a quick little double check, make sure what you entered in is correct. So then this question is asking us to find the correlation coefficient. So on our calculator, what we're going to do is we're going to once again press the Stat key. We're going to go to Calc, arrow over, so Calc is highlighted. There's lots of things on that menu. We want linear regression. We just want option number 4 is all we want. You can either arrow down and highlight 4 like I did and press enter, or you can just press the number 4. You might have a menu that pops up like I do. It might just also say linreg ax plus b. If it pops up like mine does, make sure you have list 1 and list 2. If you're not sure how to change those, let me know. Have your frequency list be empty. And we're not going to worry about storing our equation right now. We're going to go ahead and hit calculate. The correlation coefficient is your R value. And we're just going to go ahead and round that. Let's just do 3 decimal places. So we just want the single R value. So we want 0.99, and it's going to round to a 5. So R is approximately 0.995 would be our correlation coefficient. Then we're asked to give the line a best fit for the data, and that is already on our screen as well. So we're going to have y equals, and we have ax plus b. Go ahead, and it's customary to round a and b to 3 decimal places. So we're going to have y equals 39.104. X, and then plus our b, which is 220.101. And that would be the line of best fit for our data set. The last question in that first row, if you were asked to estimate your line for the value when x is 17, is this an example of linear interpolation or extrapolation? So 17, the value 17, if we look at our data set, it would fall in our data set, in between the confines of our data set, it would fall between our 15 and 20. So this would be interpolation, because it falls inside the bounds of our data. It falls inside the bounds of our data. So it'd be linear interpolation. If it was something smaller than 5 or bigger than 20, we would have extrapolation. All right, the last row gives us a chance to recall our exponent properties. The first one, we see our power rule. We have an exponent outside the parentheses. Please keep in mind there is really an exponent of a 1 on this too. So when I have an exponent outside the parentheses, I need to multiply each inside exponent by the outside one. So this would become 2 to the 4th. That's the most forgotten part, is that the 2 also gets raised to the 4th power. X to the 8th, y to the 12th. 2 to the 4th, we can simplify that. If you need to type in your calculator, you can. Remember, it doesn't mean 2 times 4. It means 2 times 2 times 2 times 2. So 16, x to the 8th, y to the 12th. In the second question of this last row, we are dividing. We have our quotient property For our quotient property, we subtract our numerator or our top exponent minus our denominator or our bottom exponent. So I have an x in the numerator, x in the denominator. So I'm going to subtract these two exponents. Please be careful when you subtract. You're subtracting a negative. So you're going to have 3 minus negative 3. That becomes addition, so you get x to the 6th. Y to the 4th, there aren't any other y's. Y to the 4th already has a positive exponent. I don't move it anywhere. So the y to the 4th just stays in the denominator. Now another way you could go about solving this, or simplifying I should say, we're not really solving anything. You could use our negative exponent rule. You could move x to the negative 3rd up to the numerator. It'd become x to the 3rd. And then use our product rule, which says we would add the exponents. So either way would be great. Third question in this last row, we see we have the same base being multiplied together. So when we're multiplying the same base, we add the exponents. So this would become x to the, we have 3 plus 5 would be 8. 8 plus another 7 would be 15. Last but not least, we see everything inside this set of parentheses is being raised to the 0 power. Anything, no matter how many terms are inside those parentheses, no matter how many variables, whatever we have, anything raised to the power of 0 equals 1. So that's it for our week 17 sheet. Rewind whatever you need to, fast forward wherever you need to, pause, ask questions if you need. That is the end for week 17.